Hello everyone, I'm Medha Malik and today's topic is dynamic memory allocation. So first of all, let us see what are the contents. So types of memory allocation, then the four functions of DMA, dynamic memory allocation, malloc, alloc, realloc and free. Now let us discuss one by one. Now there are two types of memory allocation. The first one is static memory allocation. So what happens when we allocate a memory to a variable? So this is fixed memory. So when a fixed memory is allocated, like if a variable of integer type I'm declaring, so a variable will be given the memory of 2 bytes only, right? So it will be given at a certain address value, base address value. Suppose 100 is the location. So at that location, total 2 bytes will be occupied till 102 and a will be occupying that space with certain value. Now, likewise, if I consider array, so what I have to do, if I declare array using static memory allocation, I have to initialize it, declare it with a certain number of elements that will be present. Otherwise, the compiler will not know how much memory is to be allocated for this variable a. So if I'm writing here int a of size 5, this size I have to mention, right? So now the compiler will know if this a variable is allocated, it will be given total 10 bytes of memory, right? So every element of that array will occupy space at a certain index value that is starting from 0, 0, 1, 2, 3 and 4. So total 5 array elements will be there and this array will be named as A starting at a certain address value 200 suppose. So it will occupy total 10 bytes. So 2 bytes for each element. This is static memory allocation when we tell the compiler beforehand how much memory will be allocated, right? So 2 bytes for each of the element of the array. Now, what happens in static memory allocation? Suppose we have, for smaller numbers, it is okay, but suppose we have larger number of elements. If I'm taking integer a, during the program, I require 5 more elements in this, right? Right now, only for 5 elements the memory is allocated as we declared earlier. But now if I require of 10 elements, now what will happen? We cannot change this value of array now. And one more case is there. First case, when we require more than the value, the memory that is allocated to this array. Second thing, if I require less number of element only, I have declared here that 5 elements will be there in the array, but during the program, during the execution, I come to this conclusion that I have to occupy array of size 3 only. I have to utilize out of this 5 memory locations that are given 2 bytes each. I have the members only at 0, 1 and 2 location. Only 3 values are there that I have to utilize. So in static memory allocation, we come to this conclusion. There are two things. That is, if we require memory more than what is allocated more. And second thing, if we require during the execution of the program memory which is less than what is declared. If we require memory less than what is declared, right? So in two cases, what happens? We can overcome this using dynamic memory allocation. Dynamic memory allocation. So during dynamic memory allocation, now during the program, during the execution of the program, we can change how many number of elements that you required. According to that, the size of the array can be declared using DMA. So we can do that with the help of four functions, DMA functions, which comes under the header file stdlib.h. This is the header file that we use for the dynamic memory allocation function. And what are the functions? Malloc or memory allocation, then calloc or contiguous memory allocation, then realloc, realloc, and free. So with the help of these four, by the help of malloc, we we declare certain memory space we can allocate to the array. Requested memory that is to be allocated, we can do that with the help of malloc. Now, calloc also, you can allocate certain memory which is requested by the user using calloc. Realloc, what we do in realloc, whatever memory earlier by the help of malloc or calloc we had, we can reallocate it with the help of this function, third function, realloc. And free, we can free the memory which is allocated dynamically to the pointer to the array, that we can free after the usage. So this function free is required for that. So one by one, let us discuss the four functions under the header file stdlib.h for the dynamic memory allocation. Now let us come to malloc. The first thing which you will come to know about malloc, that is, it stands for memory allocation. Memory allocation. Now, what happens in malloc? The whole size of array which is required, it is allocated in whole. Yani ki a block of memory is allocated. A single block of memory is allocated in this. Right? Then, third thing, in this single block of memory, if total 10 bytes are required, the whole single block of 10 bytes will be allocated in this. Now, what will be the initial value for the elements that are present in the block? The initial value will be garbage. So, initial value is garbage value. Garbage value. Then, third, let us see what is the syntax for this. What is the syntax? We require a pointer variable. Pointer variable, why? Because we are allocating certain memory at a location, memory location, and memory location can be denoted by, can be stored in a pointer variable. So we will require a pointer variable. So data type of that pointer variable, asterisk, then the variable name. Okay. Now, next, whichever variable we are taking for storing the address, we will store the address now. First of all, typecasting is required. I will tell you why typecasting is required. Right? Then malloc followed by size of the block. Size of block. So what will be the size of block? It will include certain n number of elements, with n denoting number of elements and into size of the data type that we require. Size of the data type. Right? So n into size of data type. This as whole can denote the size of block. So we will mention n into size of data type. Right? Now, this is the syntax for it. Now, how it will work? We have taken a pointer variable var and we have stored by typecasting. Why typecasting? Because The next point, malloc function returns a void pointer. Void pointer. Void pointer is what? Which does not have a data type. So it can store, it is a generic pointer, it can store any type of value. So we have to typecast by whichever value type of value we are using. So let us take an example. If I've taken integer pointer in asterisk ptr. Now ptr equal to, so this variable is integer, pointer is integer, so int asterisk, this is the typecasting for the pointer, void pointer, which is to be returned from this malloc function. Right now in malloc, if I have to allocate for 5 elements, so I will mention 5 into, or the number of elements that are there, into the size of, here integer values are to be stored, so I will take size of int data type. Okay, so now total, if this is there, ptr, what will it hold? It will hold the initial value of the address which will be allocated accordingly. Now the compiler will see how many elements are there. 5 elements are there, and the size of each element is of integer size. So it will allocate for 5 elements total 10 bytes. This whole block will be allocated in malloc. Now in this 5 elements are there. So index 0, 1, 2, 3, 4, right? So initial value here, when this block is declared, when this block will be allocated, initial value here will be garbage. And this address, suppose 300 is the base address which is returned from this allocation. So this value 300 will be returned as the output from this malloc function, and now this value 300 will be stored in the ptr. So ptr will store the base address of the block, which is allocated by malloc. So 300 will be stored in ptr. So with the help of pointer arithmetic, now we can uh, visit each and every element here which is present, like ptr plus 0 will give address 300 only, so we can store certain value using this address. Then ptr plus 1 will give the address 302. After 2 bytes the next element is there, no? So 302. Then ptr plus 1, after that ptr plus 2, it will jump to the next element 304 location. So next element at 304 location, it will be going there. ptr plus 2 yani ki initial address plus the 4 bytes which are allocated for earlier elements. So ptr plus 2 will denote this address value 304. So likewise we can access each and every variable that are present, that are allocated by the malloc, and we can input or access by the help of pointer only now. Likewise, so this is malloc. Likewise, calloc. First thing, it is contiguous allocation. Contiguous memory allocation. Now, in this calloc function, the initial value of all the elements will be 0, right? And here whole block is not allocated at once. Here block by block allocation is done, yani ki multiple blocks are allocated. Now again it will return a certain void pointer, right? So let us take the syntax for calloc. We require a pointer here because calloc function will also require a certain pointer variable to store the base address which will be returned from this function. So data type of that pointer is required. Suppose ptr1 is the pointer that I am taking. So ptr1 will be equal to, now again void pointer is returned, so typecasting by mentioning the data type of the pointer variable, followed by calloc, and in this number of arguments here to mention the total uh, elements that are present in the block, we will require two arguments here. First of all, n kitne number of elements hai, then comma the size of data type. Okay. So earlier in malloc function, if we see, there was only one argument that we passed in the malloc function, size of the block, which included n into size of data type. Here, both are separated. Two arguments are there when we call the calloc function. So n comma size of data type. We'll take the same example, ptr1 I'm taking, and integer value I'm storing it. I'm taking integer ptr1. Right? Now integer data type आपका है तो integer typecasting, then followed by calloc function, and here number of elements I'm taking 5 only, 5 comma size of the data type which is int. Right? So this is the syntax for it. Now how it will be allocated? Now the compiler will see 5 elements are there which are required. So one by one, I said block by block it will be allocated. So 2 bytes first will be allocated and 0 will be initialized in it. Then next element, again 2 byte will be allocated and 0 will be initialized. Then next 2 byte and 0 will be initialized. So this is contiguous memory allocation. If the base address is at 400, so at 402 only next element will be there. Then 404 next element, then 406 next element. Likewise, how many numbers of elements are you are mentioning, that will be located in contiguous memory only. So next element will be there at 408, which is the fifth element, initializing it to 0, and total 410. Till 410 the memory will be occupied. So in whole, here also 10 bytes is occupied, but block by block allocation is done, one by one only allocation is done of 2 bytes for each element, and then only it is initialized to 0, and then this base address 400 will be returned where the calloc function is called, and it will be stored in ptr1. So this base address 400 will be stored in ptr1. Now we can access again by the help of pointer arithmetic. ptr1 plus 0 we can access like we did in array, a at 0 index. So this will point to the base address only. Then ptr1 plus 1. ptr1 plus 1. Now this will be 400 plus 1 address of 2 byte. So 402. This will be the next location that will point. So 0, 1, 2, like we denoted the index values. So if we add these, it will denote the same address value at each element of each element at the index. So we can access by the help of this only. Now next is realloc function. Now what does realloc do? Like we previously declared with the help of calloc. Now during our program, I want to reallocate with the help of realloc another 5 more elements that I want to store in the array. So I'm taking int asterisk p, the pointer, I'm storing P with malloc. No. int टाइप की वैल्यूज हैं तो int asterisk आपका int पॉइंटर डिनोट करने के लिए, then malloc followed by 5 into, पहले मैंने 5 एलिमेंट्स के लिए एलोकेशन करा है, 5 into size of int. Right? Now what will it do? P पॉइंटर आपका कहाँ पे पॉइंट करेगा? जो बेस एड्रेस आपका इस एलोकेशन का होगा for the 5 elements that we are doing. So 0, 1, 2, 3 and 4. For 5 elements I have allocated. So total 10 bytes are allocated with the help of malloc. Whole block is allocated, initializing it with garbage value. Right? Now, if during the program I require that 5 more elements should be there in the array. So how I can initialize it? By realloc function. So P equal to realloc. And within parenthesis, we will mention first of all अभी किस एड्रेस पे आपके वैल्यूज हैं. सपोज 500 आपका बेस एड्रेस डिनोट कर रहा है विच इज स्टोर्ड इन P. तो P कॉमा जो आपका नया साइज होगा, द न्यू साइज ऑफ एरे विच यू रिक्वायर. राइट नाउ फॉर दिस P is the pointer where the result will be stored. Then with the help of realloc, we are reallocating which was earlier allocated at address which is present in P, comma अब नया साइज क्या है, मुझे टोटल 10 एलिमेंट्स के लिए एलोकेट कराना है ना. तो 10 into size of int. So this will be the syntax, and as soon as I execute this, now if the memory is available, if the contiguous memory is available, the compiler will move to this 500 location. If the memory of 5 is for 5 elements is allocated earlier, then another 5 is available, then only this will be allocated. Okay, add index 5, 6, 7, 8, 9. है ना? If the memory is available, then only it will be allocated, right? For 10 bytes more. So total 20 bytes आपके allocate हो जाएंगे, right? But if it is not available, then it will return null pointer. Null value will be returned. No pointer will be given the value because the memory will be insufficient in that case. राइट. लाइकवाइज मैलॉक और कैलॉक में भी अगर आपकी मेमोरी अवेलेबल होती है तो ही एलोकेट होती है, अदरवाइज नल पॉइंटर इज रिटर्न. वॉइड पॉइंटर की जगह नल पॉइंटर रिटर्न हो जाता है, डिनोटिंग दैट नो मेमोरी इज अवेलेबल फॉर हाउ मच you require. Then last, free. What happens in free? Whatever you are allocating, this P, suppose this P is the pointer that I am allocating. So after dynamically I have initialized it, I have declared it. So after allocating the memory, I have to free that also from the memory. So free within parenthesis the pointer which is to be freed. This is required for that. Right? Thank you.